Hello class, I wanted to help you with some conversions for the first water measurement lab that we will be doing for water management class. So we will be working through a lab sheet in which we are going to look at the implications of water use. So for instance, we are going to be running emitters, we're going to be running sprinklers, we're going to be calculating water to determine our efficiency of water use, potential costs of the water, and to know how much water we need to have available to run these systems. So it's an efficiency lab. So the first thing I wanted to show you is the calculations. So the first most important thing is gallons per hour and gallons per minute. And so if we're calculating, a lot of our drip emitters use gallons per hour. And so when you're talking about sprinkler systems, it's often expressed in gallons per minute. So if you're doing the conversion, there's 60 minutes in an hour, you can just multiply by 60 to get that conversion, or likewise divide by 60. Okay, one of the things we're doing is we're going to convert milliliters to gallons. And so here is the for instance. We have drip emitters called micro drips, and they have water flow. So we have beakers, and this is a 500 milliliter beaker. And so we collect the flow from this 1/8 inch line, which looks eerily like an electrical cord. So this 1/8 inch line, which comes from our water source, fills a beaker in a certain amount of time. And we're converting efficiency all the way down the line. We ran the system for 1 minute and we got 500 mils of water. So what we can find out about that is when we convert milliliters to gallons, we're taking the conversion, 1 mil is 264 millionths. There's a decimal point right here at the beginning. 264 millionths times 500 milliliters recorded in the beaker, and that was in 1 minute. The system runs 10 minutes a day, so we're multiplying that by 10 minutes, and then you end up with each plant is receiving 1.32 gallons per day. Okay, so this conversion will help you when we're running that lab. The second thing we're doing is we're converting inches to gallons. And so in this case, this is actual water recorded when we sprayed a sprinkler. This could be rainfall. We could record rainfall in the outside environment, or sprinkler usage, whether that's lawn grass, shrubs, or ground covers, or for instance in this case we did it on a nursery bench that has sprinklers spraying over the top. We recorded the water, and then we did a measurement of the depth of this water. And so this isn't precise because I'm holding it, but we recorded in most cases 1/2 inch of water. Well, I proceed to give you a conversion that works off of feet. And so we need to convert inches to gallons. And so our measurement for doing that, and our formula, is length times width times depth times 7.5, which is gallons per cubic feet. So when we're working in cubic feet, but I just showed you 1/2 inch of water that was collected, it's not in the same, it's not using the same constant. So when we put these numbers in, we need to convert inches to feet, which is pretty simple because you would convert with 12 inches in 1 foot. However, we're talking about a fraction of an inch. And so the way to do that is circled here at the bottom. There's a 1/2 inch times 12 divided by 1 foot. So you get 0.04. So in this length times width times depth times 7.5, you add 0.04 into this. So we have a bench that is 6 feet long, it's 12 feet wide, and has sprinklers on it. That's length times width, that's square footage. If you multiply it by 0.04, that's 0.04 feet. Now we have cubic footage. Instead of doing square footage, we're doing cubic footage. So the whole bench, this depth. Okay, 0.04 times 7.5, which is our conversion, gives us 21.6 gallons for the 10 minutes we ran it for to get the 0.04 feet. So this system ran for 10 minutes to get 1/2 inch of water. And interestingly enough, that's how much water we're running on one greenhouse table per day. So each table in the greenhouse is utilizing 21.6 gallons. And so those are great, efficient numbers to know to do this lab and to run efficient agriculture. All right, thanks guys, hope that helps.